Hello, everybody. Thanks for coming. Hey, I am going to be talking about software and failure, and I can't see any of you, so that's great. This is the obligatory Who Am I slide. My name is Michael Gregory. I am a site reliability engineer at Overdrive, but I started my career as a developer. Been doing that for many, many years. This is recorded, so maybe I shouldn't admit that. This presentation is focused on developers, though, not on SREs. So if you're a developer, you're in the right place. I'm also a part-time graduate student getting a theology degree. My semester ended yesterday. I did not plan that very well, but I have a presentation. I also enjoy running, biking. I'm trying to figure out how to swim so that I can do a triathlon this summer. That kind of fits in that I didn't learn to swim as a kid, and right now where I'm at is sort of the idea that I'm learning to adjust to failure in the water. Whenever I do something wrong, it's how do I recover before I drown myself? So back to your software, though, because the question is your software going to fail? Yes, it is. Okay, thanks for coming, everyone. That was a good talk. Okay, I did promise more in the abstract. That's fair. I think I'm supposed to also make it about 50 to 60 minutes. So here's what I've got. I have 5 categories of things that might cause your software to fail that we'll look at in a little bit more detail. We're going to talk about code, your code in particular. What kind of platform are you running it on? What are the dependencies you're using? That could be someone else's code. That could be an external database, something outside of your code. We'll even hit on the dreaded network. I took a networking class when I was at school, and I basically learned the internet works by magic. You throw packets out, and the next thing takes it and gets it to the next spot. That's my understanding of networks. Works by magic. We'll also talk a little bit about human error. But first, what do I mean by fail? Failure, in this talk at least, is any way in which your application does not behave as expected. Yes, that's a bit broad intentionally. I'm trying to get you to think about your application a little bit outside of the box that you normally put it in. So I made my box really big. I think there are 2 extremes that we can land on when we think about software and failure. We can be fatalistic and conclude that bugs they're just going to happen, they're inevitable, so why worry about it? We'll just deal with it when it shows up, and our users find the bugs. Or we can be overconfident in our abilities and not realize that we have a very exposed thermal exhaust port on the side of our Death Star. So, code. Hopefully, we all fall somewhere in between those 2 extremes. So, our code. This is probably the category that you most think of when you think about failure in your applications. I've been to plenty of other conferences that cover a lot of the topics I'm going to hit here, so I'm not going to go too deep into them. But basically, I'm talking about bugs and bad specifications. Did that get small? Okay. I'm going to assume you can see it because it's a giant screen, but it looks really small on my screen now, and I intentionally made them bigger today. Failure of the presenter. How do I adjust? I just keep going. Bugs. Your code doesn't do what you as the developer intended it to, or could be what the user expects it to. No one ever gets bug reports for things that are features, right? We also could have bad specifications, and this is the case where the code does what you were told to make it do, but not what the stakeholder really intended. So how do we deal with failure in our code? Or how do we prevent those types of failures? First level, we can do pull requests and code reviews. And I will admit that PRs are often not the best way to find bugs in our code. They are very good, though, at helping the rest of your team to see the code, to share the knowledge base of that code base. And sometimes you do catch some obvious issues, especially around something like configs. We can also do automated and manual testing. Automated testing is great at finding bugs. It's great at finding the things that you have thought about as, hey, the code shouldn't do X. But sometimes, again, with those specifications in particular, you were told to make the code do X, or at least you think that you were told to make the code do X, so your automated test is now just as broken as your code. And that's where some manual testing can come in. Those can be more tedious, but also more likely to find those specification problems. As an aside, Love your QA testers if you have them. They were my best friends when I was writing code that people saw because they kept my code from getting out into the world and other people finding it. Ask questions of your specifications. Hopefully you have someone in your organization that functions as a product owner or some sort of role like that that is kind of guiding your application, is responsible for what is going out. And you can ask for clarity. Anytime you get home to something in the specification, you're going, I don't know if this matches up with what the rest of the code is supposed to do or just how I think this is supposed to function based upon what I know about the users. Ask a question. Don't just blindly go in. I realize that also, particularly when we're new, whether that's new in software, if you're just starting out, or new at a new company, new team, it can be really awkward and feel uncomfortable to ask some questions. I would encourage you that if you are on my team and you're working for me, I consider people who are asking questions and thinking about the problem to be good and intelligent. That's a sign of good, intelligent coders to me. If you go off in a corner and hide and don't ask any questions, then I'm starting to worry about you. Ask questions. And yeah, I know that there is a little bit as you gain experience, there can be the idea of, oh, I should be more independent, but balance that a little bit. Ask some questions. And finally, in this topic, work on short cycles. The less code that you can produce before someone has to go and review it, the more likely it is that you catch an issue. There's less code that has to be checked, smaller amounts of time, or less time. You don't need to spend as much time producing it or reviewing it for your stakeholders, so they're more likely to catch some of the little things. Okay. The next section is the platform, and this fails depending upon your platform. And this is probably one of the impetuses for this talk is as I've moved from being a developer to an SRE, where I am responsible for keeping other teams' code running, is realizing that as developers, we don't always think about where is my code running on? How could something going wrong with that platform affect my software? Because the ways in which a physical server will fail are different from the way a cloud provider might fail. A virtual machine shares a lot with a physical server, but there are still some differences. What I'm not saying there is that you need to understand all the intricacies of your platform. For many developers, you don't want to know about the server. A major reason why we use cloud platforms and containers is to abstract away a lot of those details. That's fine. But every abstraction also introduces new points of failure, even as it solves some. The team that I work for at Overdrive manages Kubernetes clusters that host other teams' applications. Several of these applications have been migrated from VMs or are similar to apps those developers are familiar with running VMs, like simple websites. And I have some visuals for this on the next slide, but part of how we have we've seen different things that they do that are the same as how they would deploy on a VM that end up causing problems in Kubernetes. So how do we prevent these types of failures? Know your platform, or at least work very closely with someone who does. My team works closely with the search team at Overdrive, so they actually don't need to know as much about what's going on underneath because we're working closely, we understand their application, we know what they're trying to do. But then also, when you know your platform, think about what's its advantages and what are the disadvantages. It can be easy to go, oh, the cloud is the best, without thinking about, well, what do I lose by going into the cloud? So, Kubernetes deployments. This is a thing that I have seen a few times is that suppose those white boxes are Kubernetes nodes, and the blue is your application. I've seen many people, when they deploy their very first app, go, oh, it's a website. It doesn't need to be highly available too much, but they'll put one instance. When what we probably should be encouraging you to do is have 3 replicas, because now you are at the mercy of the Kubernetes scheduler or at the mercy of me as the Kubernetes admin. And occasionally, I need to do some maintenance, and I go to node 1 and I take it down. If you had this version, your app just went down until it can get rescheduled. If you have this version, your app's still up. Except there's one small problem. The scheduler doesn't promise that. It might do this. If you do not specify that you want your nodes to be apart from one another based upon the host name or some other rule, it's going to schedule it wherever it has space. And if I just drained node 1, brought it back up, and then you deploy your application, it might put all 3 of your replicas right there. Just something to think about as you move from platform to platform. So are dependencies. How do they fail? It depends. Okay, I got a sympathy chuckle. I'll take it. How will you experience failure with your dependencies? Depends. The farther we get from the app, the more options and ways that it could go wrong. And the less I can directly help you in a talk like this. I'm just trying to give you categories of what to think about when you're approaching your application. If it's a code type dependency, there could be bugs. It could be that you have an external dependency like a database server or some cloud option, some API that you're trying to call. Those can all have outages. A full outage can be particularly annoying, but they can also be really easy to anticipate and plan for. And what are you going to do if this database is down? What do you do if this external web API that you're dependent upon goes down? Dependencies can also have their own failure conditions. Uh-oh. This off? Okay. I'm going to hold a mic. Nothing could go wrong. Always have 2 different microphones. Failure. Planning. It's the best. Dependencies can have their own failure conditions themselves. We'll get back to that one. How can we prevent these types of failures? Choose your libraries carefully. It can be very tempting to either not use other libraries and write all your own code, or to use a library that looks cool but has 5 users. Find libraries that have been used and battle tested in the real world. They are more likely to not have bugs. Also, keep them up to date. I know that can be annoying, but less likely to have bugs again. Also, though, it does introduce another layer of testing. So solve one problem, introduce a different one. Balance. Again, know your dependencies just like you know your platform. Think about how they might fail. And is there any way in which your application can degrade gracefully? If your application has a database that is heavily dependent upon, it's down. But if you're calling some sort of web API, maybe you just lose that functionality of your site. And then, is anything else dependent upon your application? One thing that I am aware of as I'm giving this talk and planning for it was the fact that the more you attempt to anticipate failure in one place, the more possible it is, the more complex your system is especially, the more possible it is that you introduce failure in a different place. So, in a way, I might cause problems for you by encouraging you to change something to prevent a failure. Don't fall on that extreme, though, where you just go, oh, yeah, there's nothing we can do. So, an example of this. We use at Overdrive both Kafka and RabbitMQ. These are 2 message broker systems. You can send messages between different apps or within different services of an application. But suppose that we have both of these. And we want to write a message into the queue. And for right now, either one of these, they're going to behave about the same for my purposes. So we write a message, we write another message, and maybe these boxes are not just single messages, but they're thousands of messages. What happens when the consumer gets behind in each of these systems? In RabbitMQ, there's a back pressure mechanism because it's concerned about how big the queue sizes are getting on its server and its ability to perform when queues get larger. So it throttles the producer. Kafka will put the burden entirely on the consumer to keep up. If the consumer can't keep up, too bad. We're just going to allow more data to go in. Does that make one better than the other? Maybe for your application. You got to think about what is going on in each of these different services that might help you or hurt you. If you have a web API, for example, that takes a user request, writes a message into your message broker, and then waits for it to be acknowledged before writing back to your user, you are eventually going to have a bad time if you're using RabbitMQ in that case, and things will eventually fall over. Which brings us to the network. It's always the network, isn't it? Sorry, network engineers. Except I'm really using the network as a stand-in for anything that's outside your application, outside of your control. And yes, there is overlap between some of these categories. The point isn't to determine whether an AWS outage falls under this platform category or it's the outside category. It's how is your application going to stop functioning? How does it fail? You don't know. That's the problem with it. And how can we prevent these types of failures? In a lot of cases, we can't. Sometimes, maybe, we can think about some of the things that might go wrong out there in that network where we shove packets out and hope they get to where they're supposed to go. But we can have plans for detecting and handling incidents. Monitoring and alerting is another good topic that deserves its own talk, maybe next year. But there are a lot of good monitoring resources on the internet already. So here's what I would add in really quick. Focus your alerting on detecting issues your users would actually see. If you know that high CPU on your API is an indicator that it's about to fall over very soon, and it would help to go address that now, wake someone up for it. If high CPU is more of a symptom of something that you might need to address in the future, but it's not an imminent problem, probably, it's not time to wake someone up for. At least I don't want to be woken up for that. I want to know tomorrow morning when I come in that, hey, there's high CPU on these servers. What can we do about this? Is there something bad in the code that's going inefficient? Are we just seeing a lot of traffic and we need to scale up? But as long as it's handling the requests it needs to at 2 a.m., I'm good to let it keep going at 2 a.m. But then after that, collect as much data and make it as easy to see that as you can. And this might be, if you are a true developer and you don't think about metrics and stuff, this might be a place to find an SRE or an IT person to help you. Figure out how to make dashboards. You want to be able to understand your system health at a glance. Again, if you get woken up at 2 a.m. because your software is not serving requests to your users, you don't want to spend time trying to remember how to query your metrics database. Sorry, I moved that. You don't want to spend time trying to query your metrics database. You want to just be able to look at a dashboard and see what's going wrong as best I can tell with my application. Also say, don't fall into the trap of assuming you understand the problem. It's easy to say, it's the network, and then do nothing while you wait for someone else to fix the issue. But what if the issue isn't really the network, and it is actually something with your application? When we first started using Kafka at Overdrive, after we had sort of moved out of the prototyping stage and into real use in production, we started observing an issue in our dev cluster where our producers were getting frequent network timeouts. So, obviously, it's a network problem, right? Talked to our infrastructure guys. They said everything looks fine. Everything's inside. This was all internal, so we weren't going out to the internet and back in. We checked that too. Every other application on this network was running fine, could not find anything. So all of us, devs and IT guys, infrastructure, were completely stumped. It turns out we didn't rebuild the servers from our prototyping stage. So they were kind of just put together with leftover hardware that was out of warranty. The dev cluster had each server in the dev cluster had a single hard drive with a spinning disk. The problem was that the disk head physically could not move from point to point fast enough to keep up with all of the requests coming in. It wasn't the network. We solved that, by the way. The servers now have, those are all now SSDs. They're all nice and fast. I think they're actually in one of our storage drives. So, fortunately, dev, not prod. But that also goes back to platform. Know your platform, or make sure someone is paying attention to what the application is going to do on this hardware that you asked them for. So, the outside, it could be that you face this guy. Or worse, this one. And that brings us to human error. Again, these are all going to be examples. My list is not exhaustive at all. The nice thing about this one is if I take a drink, you can't hear it. Some of the ways that human error can cause problems is we skip steps in manual processes. No one in this room's done that before, though, I'm sure, right? We might have a config change that happened directly on the production server that was never committed back into a build deploy process or into the right code. No one in this room's ever done that, I'm assuming, either. Or at least people out there haven't. People standing here definitely have. You could also manually build the code and deploy it, and so it's now different from what would have happened if you'd built it through the process, because any number of reasons why the compiler was a slightly different version, you passed a different flag to the compiler inside the IDE that wouldn't have been passed in your build config. Manual builds can be different and cause problems. So I like, and especially as an SRE, automate everything. The more automated things, we reduce places where a person can forget something or introduce a difference from what's in source control. Manual changes are easily overwritten or cause uncertainty over what is supposed to be there. Has anyone ever gone to a prod server to look at what's the config here and realize, wait, that's not what's in the process? And then you have to ask the question, well, which one's it supposed to be? Is prod wrong? On one hand, it's prod. Prod can't be wrong. But what's going to happen when you deploy? Have build and deploy pipelines you actually want to use. Do not create excuses for yourself to go around the process that you put in place. If you don't like your builds, and I realize they're builds, at some level, they're not going to be your best friends probably, unless you're me and you're weird. But if you actually hate running through the process, either because it takes too long or there's too many, there's, again, manual steps in it for some reason, figure out how to fix that. You'll thank yourself later. Store as much configuration as you can in source control. We use Octopus Deploy for a lot of our stuff. They have a new feature now that allows you to put your configuration for your builds or your deploys directly in your repository. So the repository can be the source of truth for even how your build works. If you have build scripts, repository. This gives you the chance to see what changed, when it changed, and if you have a good commit message, you might even know why it changed. That too. For the people not in the room, link your tickets. Have an escape hatch for emergencies, though. Sometimes things fail and you really, really need to push a fix. Maybe GitHub went down and you're using GitHub Actions. That's never happened in the history of using GitHub, I don't think, but it could. I think it actually happened the day I was writing this. I have access to production servers, but I only want to use that if something is actually broken, either because there's a production outage or something's going wrong in that build deploy pipeline itself. But those exceptions should be documented. If I do something in prod, I'm writing it into the relevant Slack channel. Everyone knows I'm trying to make it as public as possible, too. I'm not putting it in our private channel if I can. It's going in a public channel that says I made this change at this time for this reason. And as soon as we can afterwards, we want to correct and redeploy the problem, and redeploy it even if you're deploying exactly the same thing to make sure that you don't run into that confusion thing of the build pipeline says version 1.6, but the code says 1.6.1. Which one is it? Is it that's the Star Wars version of This Is Fine, right? The original? Okay, if I'm on a slide called Final Thoughts, I am talking way too fast, which means I have time for all of these optional things. Cool. So this is Final Thoughts Part 1, which might not make sense. Stop making failures personal, both for yourself and for your teammates. It helps a lot if you can start to build a culture wherein you expect mistakes will happen and that you can try to learn from them. I'm not saying avoid accountability. It is good to hold ourselves and our teammates accountable and learn and grow from those mistakes. But if you get into a blaming situation in the middle of trying to solve something or immediately after, you're really not solving the problem. You're making a problem harder and worse. Accept that failures happen, at least if we're going to use my very big box definition of anything that isn't what you expect. Prepare for failures when you can. Again, and that's kind of what I'm really saying today is think about what could go wrong, be prepared for it. Break all the things in dev, because the more things you can break in dev, the less likely you are to find out that they broke in prod and that your users found them. Don't make your users find your bugs. It's really rude, and eventually they stop being your users. But I will take people who like to break dev all the time and will find what works, what doesn't work, and make sure that what goes out is good. Also, if you start thinking about this, if this is not something you're regularly practicing and thinking about failing, do start small. Don't go, oh, there are 7 different ways that my application could fail that I have just thought of in this talk. Pick one. Go do something with it. Again, if you fix 7, that's not small cycles, that's not thinking small. You're more likely to cause more problems than you are solving. And the answer for a particular failure case might be to do nothing, or even just to set up an alert. Just because you can put your app in 3 different cloud regions doesn't mean you should. As an example, if you have an application that you want to generally be highly available, you could put it in 2 different Azure regions, 2 different AWS regions, Google Cloud, pick your provider. And that way, if one goes down and has an issue, the other one's still up. But how often does that happen? It's very obvious to the world when it happens because a third of the internet doesn't work. But is everyone concerned that your application's not working if Netflix isn't working? Maybe. Again, your app, not mine. Think about what goes wrong. But if you have it in 2 cloud regions, you're now paying for 2 cloud regions. So at some point, you have to make the decision, is the cost worth the extra region? Is the extra work that you have to do to make sure you can deploy to 2 different regions actually gaining you something? So maybe the answer is to do nothing. Before I worked at Overdrive, I spent 5 years working for a company that was a contractor at NASA Glenn in Cleveland. We did risk management. Well, I wrote software. The company did risk management. But that meant that I got very familiar with this chart. And what this is any sort of issue or incident gets assigned a value from 1 to 5 on likelihood and severity. And then you figure out what color it is. Solve the problems in the top right. That is the right. Yeah, top right first. My left, your right. Don't worry about the green stuff as much. Figure out how you're going to deal with the things that are going to cause the most problem, could cause the most damage to financials or reputation for your company, and also which ones are most likely to actually happen. So, I've talked a lot about technical things. I find that sometimes getting out of the technical and thinking about an example that's the same area but non-technical can be very helpful. For me, public speaking is one of those things that I have to think through, how am I going to plan? Apparently today I just speak fast. I get really nervous when I'm standing in front of a room even this size, and knowing there's 2 more rooms and I can't see any of those people, I have no idea how many people are there. This is going on YouTube. I come in and I think about, okay, how am I going to get through this talk? About this point in the talk, I'm fine. I'm comfortable. I'm happy standing here talking to you, making bad jokes. But for the first 5 minutes, I know that I'm going to have a problem. By the way, aside, If you are nervous speaking, don't tell your audience you're nervous at the beginning of your presentation, because if I'm in the audience, I'm paying attention to how nervous you are, not what you're saying. Tell them at the end like this. But I come through and I think about, how am I going to deal with that nervousness? What will I do? A lot of times if I have a podium, I'll come in and put my hands flat on the table, and if I'm shaking, and that gets me to calm down. That doesn't work when you have to hold a microphone. This is getting really heavy too. Keep switching hands. Hope that's not too distracting. Thinking about, what am I going to do with my hands though? What are you going to see? It's very natural for me to want to put my hands in my pockets, and then you're all sitting back there thinking, what's he got in his pockets? And is this a riddle from The Hobbit? So it's just thinking through, what am I going to do when I get nervous? Recognizing that it's a very good possibility that I'm going to have some sort of reaction, and how do I deal with it? I also get migraines. This light is my best friend right now with all of the sarcasm possible. I'm wearing a hat just to help with that. I normally would try not to when I'm speaking, because I feel like you can't see me as well this way, especially if you're all the way up there, but you chose to sit there, so your loss. Maybe it's your gain, I don't know. But a lot of times I have to think through, when I'm scheduling my week, what I have to get done. I'm thinking through, what happens if I get a headache here? Am I going to be able to adjust? How do I have margin? What are the most important things I'm doing, and when do I need to make sure that I absolutely have my medication with me? When have I taken a dose, so that I'm good? It's just thinking through those little things, and probably a lot of things similar that you're now thinking of, oh, I do this in my normal life. I think through, how am I going to plan for when something goes wrong? Who wants to hear about the Kafka catastrophe? Okay, I have some hands. I can kind of see them up there through the light. This is one of my favorite stories of failure. I gave it a bad name, or a punny name, I guess. In 2018, or probably a little bit before that, in 2018, the European Union passed a thing that we know as GDPR. Anyone know what the GDPR does? Yeah. We had some PII in our Kafka cluster with indefinite retention. GDPR says that's bad. So we solved this by basically forcing the topics. The topic is, when you create data in Kafka, it's stored in a thing called a topic. That's kind of a queue, except it persists on disk for multiple consumers to try to consume over time, and you set a retention policy, in this case indefinite, or there's a special retention policy called compact, where you give it a key and a value, and it keeps only the latest version of the value, or the latest value for the key. Kind of. There's still a garbage collector that has to run to actually go delete that older data. And Kafka will not clean up the current active segment. So you basically have to force your segments to roll at least once every 30 days, which is generally possible because we patch and reboot, which should close segments. But things can go wrong, and a segment might not get closed for various reasons. Maybe patching failed that month and we just didn't notice for some reason, and we get past 30 days. Or the data has been held for more than 30 days, or we get the request late and we have to delete it quickly. So we want to be able to automate this process so no PI sticks for more than 30 days. So we changed on a global scale, not for the right topics, all the topics in Kafka. We changed it so that there was policies on when segments got rotated. And we applied this at about 5 p.m. Okay, I'm glad someone appreciates the sadness of making big changes at 5 p.m. Don't do it. It's not worth it. We ran out of file handles on the server. It was set to something absurd like 200,000. We ran out in about 5 minutes because we had started closing and opening brand new segments on all of our Kafka topics at the same time. Simultaneously, we found an actual bug in Kafka where if the server crashes for some reason, like it ran out of file handles, open ones could get corrupted, which is generally okay on a small scale because there's replication and extra copies, and it just recovers that from the other server. Except when it corrupted, it didn't know that it needed to be re-replicated, so we had to find all the corrupted segments and go delete them so that it would get re-replicated. So we've got both of these at the same time. We don't know that. It's now 7 or 8 p.m. My entire team stayed and helped working on this. And by the way, this is a failure in communication, is they all thought they had to stay to help me solve this problem, which I didn't expect of them. So make sure your teams in these types of situations know what's expected of them for helping to deal with it. But I was very grateful they did, except for the part where I got outvoted later that night. I was right that time. We thought the issue was limited to one server, or that was a possibility. We hadn't quite tracked down the whole corruption bug thing yet. We decided to completely delete all the data off one server and let it re-replicate from the others, which just compounded our problems. Know what your problems are before you do drastic actions. I was awake until about 4 a.m. I eventually involved staring through logs, parsing logs, filtering, and fortunately we had good logs that were structured, and I could go look for specific keywords and found all the corrupted segments, deleted those. That took me multiple hours of basically playing whack-a-mole. Until 4 a.m. And then it looks like it's running, and then it would run for half an hour, and then find another corrupted segment, fix it, run for a few more hours. It's now a Friday, by the way. We did this at 5 p.m. on a Thursday, just to make it worse. At least it wasn't a Friday, but I basically spent all of Friday then just trying to watch this thing because it couldn't replicate the server because it was too busy trying to solve all the corrupted segments and stuff. So that was sort of the Kafka catastrophe, is a bunch of things that went wrong at once that we could have prevented if we thought, hey, how can we make this change small? How can we focus the change we need to make on only the data that's affected it? Which, by the way, is how we have things set up now. Anything that needs to be forced retention so that it can't live past 30 days, we do that, and it's targeted to those specific things instead of being applied on the global server level to make sure that it could be retentioned out after 30 days. Again, we had logs, but we found places where we could improve our structuring so that it was easier to search and filter through. And also I learned to tell my people when they needed to stay, when they didn't. Questions. Taking live questions is dangerous, but I'll try it. Is there anything in Discord? I don't know who's supposed to check that. Comment, not a question. That's good. No questions. I'm going to get in trouble if I let you out this early. Someone has to have a question.
How do you account for situations where, because of institutional momentum, you can't have your staging environment or your dev environment be an exact replica of how things are set up in prod?
Okay. So I'm going to try to repeat that for everyone else, and you can tell me if I got it right. How do you account for if there's just organizational reasons why your dev environment is not a mirror of your production environment? I guess that will fill some time. Alerts are good, yes. We do have, I have worked in a couple systems that are like that, where the dev and the prod are different, and it is trying to figure out, okay, what is this case? One case, it was particularly dev database performed significantly worse than the prod database for a period of time, just because smaller hardware, because we want to save money in dev versus prod. And that's now better too. But we kind of accounted for it by saying, okay, how can we release this change incrementally in prod. How could we put a feature flag on it, for example, that only, or gate it so that only a certain percentage of users actually see that change? I don't know if that's something that would be possible for you. We do that with some of our deployments. We roll them out. We're using Trafic load balancers, and we can actually control how much is a blue-green kind of thing, how much goes to this version, how much goes to this version. Those are the things that at least immediately come to mind off the top of my head. If I didn't quite get as much as you're thinking, maybe stick something in the Discord, and I'll try to follow up next week when I can think a little bit more and not stare at a light. Nobody else? Yeah, someone commented in the Discord that even outside environment can cause things to fail, like heat. Things getting too hot. The air conditioning going off in your colo center can cause some problems. Good? Okay, they'll only yell at me a little bit, I think. Thanks, y'all.